All right, guys, we will start now. I'm so sorry that we are starting so very late. I didn't envisage it at all, but we have so much to cover today. Let's see how far we can go. Okay, so can we all see my screen?
Yes.
Okay, nice.
Yeah.
Okay, so I was explaining static testing. I said today we are going to cover static testing, dynamic testing, and testing techniques. Okay, so I'm going to start from the beginning again. Static testing basics, review process, and test documentation. So I said static testing is all about checking the software that has been developed and comparing it to the code or to the work product. When you're talking about work product, you're talking about the specification document, your test cases, your test ways, um, the design document, the architecture layout, and all of that. So you are not executing test cases, mind you. All you are doing is just comparing documents to the design, comparing designs to implemented softwares, all right, or implemented application. Okay, so that is the basics of static testing. And we said the benefit of static testing is numerous, from identifying and correcting defects to checking requirements and comparing it to the software to check for inconsistencies, ambiguities, contradictions. It's possible that some requirements were misinterpreted by the developers while they were developing the application. Um, so you're trying to check for those defects. Not like you are not executing the test cases, you're only checking and comparing. All right. So it has benefits. It reduces development time, it reduces testing time and costs, and it reduces the total cost of quality. All right. So that's the benefit of static testing, as you can see. So it also improves communication between teams. You're able to communicate what it is that has been implemented, what the defects are, and areas that need to be changed and fixed, and all of that. So that's the benefit of static testing, and you can run a static test on applications that you are not used to or that you don't have a domain knowledge on. So while reading through the BRD or your test plans and all of that, especially if your test cases were not developed by you, were not scripted by you, it is possible that you don't really understand what the application is all about. Because of that, it's better to conduct static testing first, so as to get familiarized with the application and with the documentations. All right. So the next thing is work products review process. So I mentioned that work product includes every documentations and informations that you need as a software tester, and that includes review process, um, um, it includes your BRD documents, your test plans, your everything. That's what we call work products. And there's a review process for work products. For every documentations that you see, especially those BRDs, test plans, and all of that, before you can actually make use of them, they have been reviewed. All right. They have been reviewed from one person to another, and not just reviewed on documents alone. They've conducted review meetings on them. All right, before you can actually say, oh, we are working with this document, we are working with this function, and all of that. So that is what we call review process. And there are different kind of review. We have formal review, we have informal review, and We said every review consists of planning, then you initiate the review, and there's also individual review, there's issue communication, and there's analysis, and then fixing and reporting. All right. Then people are still joining, so let me just. So we said roles and responsibility of a formal review. So in every review or review meeting, there's always an author. The author of the document, that's the initial person that wrote the documentation. All right, and there's always management, there's facilitator, there's a review leader, there are reviewers, and there's what, a scribe. All right, it might not flow like this from one organization to another. It depends on the company. In some companies, they might not have facilitator, but they might not have scribe, but that scribe is really important. Also, there are different kind of formal review, like we said the other time. We have informal review, we have technical review. All right, so let's go through it one after the other. There's informal review. You say this informal review can be performed by a colleague, an author. It can also be like a peer-to-peer review. An example of the kind of review you do when you are reviewing your test case document. All right, and reviewing your test case document, you have two, three, four people on it. Maybe the first person has written everything roughly, then the second person comes in, review it, adjust the actual result, adjust expected result, adjust, syntaxes and all of that. All right, so the review process continues like a chain reaction. It continues until like the final review is done, probably by the team lead and all of that. So you know that there is an author to that document first. All right, like we said, there is always an author. There are reviewers and all of that. So in informal review, for example, we have those kind of we have informal reviews in agile setting. Like we talked about agile setting last week, there is a methodology in software development, and in agile setting you work in the right room. Okay, someone is asking if they're in the right room. Yeah, you're in the right room. This is the new meeting link that we are using. Because of volume, we had a technical difficulty with the initial link. So I thought it was my device, but it was not device at all. So yeah, let's continue. So we said there's informal review, and it is always done in an agile setting, and it is usually common with agile people. They do things informally. You can easily walk up to your team leader and say, oh, this, can you help me go through it? And they just check it, and this code is not working as it should, and then they just quickly run something very fast on it. So this kind of reviews happen in agile setting. All right, can be performed by a colleague, can be performed and may not involve a meeting, may not really involve a meeting. So we have walkthrough, we also have walkthrough, we have technical review, we have inspection. So let's go through the remaining three. We have walkthrough, technical review, and inspection. So walkthrough is when a meeting is conducted and then there's a scribe to it. A scribe is that person, like a secretary, that pens down all the changes that is being made. As they are noting those changes, this person is penning it down, putting it down. All right, and checking for places to effect the changes. All right, so that is the scribe. So we said review happens at any point, maybe from software product, what's the name now, from requirement gathering. When you are still gathering requirements, you can do reviews on your requirement document. All right, you can also do reviews after the requirement document has been finalized, when it is being passed on to the technical people to draw out their technical requirements. They do review meetings. From technical requirements, it is passed on to maybe the business people and all of that. Those ones do their own review. Then from that, it probably gets to the tester, and then the tester will say, oh, this thing, and then they review it also, and so on. That's for BRD. Okay, when it comes to product design too, maybe the UI UX designers, the way they work. they initialize the meeting first. Okay, that's where they pitch the idea of what the software will do to the designer, and then designer look through it, and then he starts start his design process, maybe using Figma, process flow diagrams and all of that. So from there, from the first design, you have review of the designs. Maybe it goes straight to head of product design. From head of product design, it goes to the business people, and then they check, okay, this is what the design people have done, does it comply with what we want, and all of that. So that is how review process goes, and we are saying that this review process are different depending on, where you work and what methodology is being practiced there. We said there's informal, there's walkthrough, there's technical review. As you can see here, we say technical review, reviewers should be the technical peers of the author and technical expert in the same field or discipline. An example is when you have a gathering of software testers and you have a security expert, then you have a performance tester, and then you have an automated tester, and then you have a functional tester. Okay, all of these are testers, of course, but they have their special, they are technical expertise, right? They have their disciplines, and then maybe they are just there to review a document that is detailing the business requirement for an application, maybe in the security line, or maybe in telecoms line and all of that, and then they are there reviewing the document. So sometimes before the meeting, an individual comes up and then does the preparation, and then it's the person that will now present and all of that. So it is ideally led by a trained facilitator. We said a scribe is mandatory here. Why? Because they need to pen down important changes. It is a technical review, so it has to be noted, penned down. So there's also inspection. It follows a defined process of documentations and all of that. So in your spare time, just go through them. So we have applying review techniques. There's ad hoc, there's checklist, there's scenarios and dry runs, there's perspective based, there's role based. Role based, we are talking about probably we have different users of the application. There is the customer, there is the salespeople, and there is the marketers, you know, there is the managers, and so on. So if that's what we call role based, and scenario based is, when we get to scenario test scenarios and all of that, we understand what we mean by scenario based and all that. Checklist is like there's a list of things to be checked for, and as you're checking it, you are marking it. All right. So ad hoc is just the general, or by default, the review, a kind of review that you conduct general on an application, like what we call ad hoc by default. All right. So let's just move on, because we still have a lot to discuss tonight. Okay, so test documentation. So I just put this one in, and we will not do much on it this week until next week. We'll be focusing fully on test documentation next week. So test documentation are artifacts, you know, or you can call them documents, work products that a tester required to be able to do their job properly. All right. So it is a complete suite of documents that allows you to describe and document test planning, right? Test design, test execution, test results that are drawn from the testing activity. So that is just what test documentation is all about. All right. So we have document that involve test planning, test design, test execution, test result. You notice that these words that I'm mentioning are not new. We talked about test planning last year, right? We talked about test when we were talking about test level. We said there is the planning, right? We said there is the what? Analysis, there's design, there's execution, right? And there's closure. Am I right? So if you paid attention enough last week, you will understand that all of these words are not new. All right. Adedolapo, you will ask your question after the class, but I hope you cannot hear me.
No, ma. I
You
can
can't hear
barely hear
me.
you, ma.
I can hear you.
I
loud
can
and
hear
clear.
you
Oh,
clearly.
great. So someone can hear me at least. So Red Dragon, maybe you should leave and join again. Like try to close to leave and then join again. All right. So let's continue. So we said, what is a test scenario? A test scenario is defined as any functionality that can be tested. It is also called test condition or possibility. As a tester, you put yourself in the shoes of the end user. So when you have generally gone through the all the documents, you fully understand what the software is all about. You've gone through the design, the workflows, all right. So now you are putting yourself in the shoes of whoever we use the application, whoever we use the software, and you are looking through their eyes, through their perspective, and you are checking for possibilities, right? And sometimes it's not just the users it's not just the end users alone that the application is meant for. There are also business people that use application. So there's B2B application, there are B2C applications, that's business to business application, business to customers application. All right. So so test scenario, we actually define what functional for the functionality based on the possibilities or test conditions for an application that is under test, or for a software that you're about to test. That's what it means. So it means that from reading of requirements to predicting the user usage to determining scenarios, possible scenarios, to creating traceability metrics in some cases, and then to reviewing. All right. So you have your what? Your test scenario. We will do more on this one later. It's actually very important. So I did not want to just summarize it the way I summarize it. But then we have a lot to cover here. So let's just continue. We'll come back to it. So we say, what is a test case? A test case is a set of actions executed to verify a particular feature or functionality of your software application. So a test case contains test steps, test data, conditions, post condition, and so many things depending on your, like I said, this thing is not just black and white. All right. So some templates, some people their template is different from one organization to another, and also depending on the kind of software you're also working on. So but certain things are definitely important when designing a test case. Number one, the test ID. The test ID is identifying that, okay, this is this test case. Okay, so it's an ID. So your test ID is important. All right, the identity of the test case. So your test scenario or use case is important. The test name or description is important. The expected result is important. The actual result is important. Execution status is also very important. All right. So when designing your test case, all of these things should be noted. So by the time we get to the phase where we are designing our test cases, now you've seen how it looks like. We have ID, the use case, we have the test name, the description, expected result, actual result, execution status, and all of that. All right. So you are saying that. So what I'm trying to say is that when you have a scenario, then you have a test case. So a test case is cascaded into a scenario, meaning that you can have several test cases within a test scenario. All right. It's just like an example of what we talked about last week, an ATM software. Within an ATM software has a lot of function that it performs. But if you have a scenario where the only thing the user wants to do is to change his PIN, maybe it's a new ATM card, credit card. All right. So and this user, the only thing they want to perform on the on that machine is what? Is change of PIN. So we are saying that the scenario for this case is what? Change of PIN. But while the user is trying to do change of PIN, there are a lot of test cases under what? That change of PIN, right? So what will the customer do first, or the user? The customer will what? Insert the card. Inserting the card is what? A test case. Alright. So inserted what other thing? Probably the user or the customer enters All right, the new pin. All right, that's also another test case. Another test case will be to confirm what? The new pin. All right, now another test case will now be to what? To retrieve the card. All right, so what we are saying is that is a set of actions that you to verify a particular feature or functionality of a software application. So in a big software, you can have as many as 2,000 test cases, as the case may be, even more. All right, and you can have as many as 200 scenarios. All right, so you have scenarios. Yeah, you have your software cascaded into your test scenario, and then your test case. So from test case being a subset of test scenario, and test scenario being a subset of what? Of the application on that test. Right, so that is how you write your test case. When we get to that part two, you will understand. Let's move on. Okay. So we said how to write a test case for manual testing. Number one, you have to keep a simple mind. Okay, so it is simple, it is not difficult. That's the first thing. Calm yourself. It is simple, it is what? It is not difficult. The second thing to note is keep end user in mind. All right, keep the end user in what? In mind. Who are those that will be using this application, this software? Who is it meant for? Is it for business owners, small medium enterprise owners? Is it for university students? All right, and is it for all users in their different categories? All right, so you have to keep in mind the end users. All right, then you have to avoid repetition. All right, so you are saying that ejecting the ATM, and then you're also using another word. All right, so checking that the ATM, checking that you can actually retrieve your ATM is like saying rejecting the ATM, or the machine ejecting the ATM, or the user remove the ATM, and then you're using different grammars to describe the same test case. No, avoid repetition. One action, if it is for one action, then it's one action, so far it doesn't have other condition attached to it. So it is not repetition if it has other conditions attached to it, because it's one case to it's when we get to conditions, preconditions, business rules, and all of that, we'll be talking about how well you can avoid um repetitions. All right, so another thing is, do not assume. Another thing is, do not assume whatever is not there in your requirement document or in the design. Don't put it there in your test case. Don't assume. If there's nothing that it's not clear, then you should find out. Otherwise, just remove it. So don't assume. Ensure 100% coverage, and don't try to, under do not assume, don't try to pack two test cases together in one. You can have problem when you start testing. So don't assume, don't pack two test cases together, three tests to get tests together in one. Try to separate them as much as possible. Then ensure 100% coverage. Make it identifiable, like we said. We've talked about ID the other time. Use testing techniques. We will talk about testing techniques right in this class. So you understand what testing techniques are. So when you are performing your test, you should understand that the kind of test you conduct on A, maybe you are performing what's the name? Maybe you are performing boundary value analysis on A, then you are doing decision table analysis on B. So there are different kind of testing technique. When we get there, you understand. We have self-cleaning, we have repeatable, we have peer review. All right. So we've talked about peer review, and I hope you understand what review and peer review is all about. Let's continue. We have okay, so we talked about static testing the other time. We said static testing is static. You are not executing test cases when you are performing static testing. But the opposite is what? Dynamic testing. Dynamic testing, you're actually executing test cases. So for this part, we'll be considering dynamic testing, categories of tests technique, black box test technique, white box test technique. By now you should be used to what black box means, what white box means. All right. Then experience based test techniques. All right. So if you recall, we talked about black box testing last week. All right, and we talked about white box. If you can't remember, try to refresh your memory by visiting last week lesson. All right, uh, last week lesson. Let's continue. So we have dynamic testing. I would say there are different types of dynamic testing. You know, dynamic testing is you executing test cases, right? And checking to see if they pass or fail and all of that. So we have black box testing and we have white box testing. Other black box testing we talked about last week. We have functional testing and non-functional testing. We also have under functional testing, unit testing, integration, system acceptance. Is there um in your in the PowerPoint for last week? Okay, so we also have some other kind of testing: non-functional testing, recovery testing, functional testing, security testing, compatibility testing. You know what compatibility testing is? Compatibility testing is checking for devices or browsers, or how well an application will perform if they are used on other devices, on other systems, under different operating systems and all of that. So it's like saying if I open this web page on my phone, will it work well? If I open it on Chrome browser, can I compare it to how it will open on Firefox browser and all of that. So you are checking how compatible the application is with devices, with operating systems and so on, with browsers. So that's what we call compatibility test. Let's continue. So we said dynamic testing technique is a technique to testing your application, and when you are testing your application, you have to put them in mind. All right. So why after designing your test cases and you want to execute your test cases, there's a way even before writing your test cases, when you have gone through the BRD and you've seen what function you have to test for, there's a way you have to write your test cases such that they have to fit into all these different types of testing technique. All right. So we said okay, before I continue, there's something I need to show you. I almost forgot when we were talking about reviews. All right, let's go back. um I don't want to miss that out, so we have to go back. Okay. We said there's always an author, management facilitator, review leader, reviewer, scribe, and all of that. Whenever you review documents or you attend a review meeting or a work product is being reviewed and all of that. Okay. So I have a sample document here which I wanted to show us. It's an old document, and as much as possible I don't want this class to be just theoretical. I wanted something you can understand. Okay. Give me 1 minute. I opened it earlier. Okay, it is closed now, so I'll open it. Okay. So let me share this particular screen. Share. I don't know if it's this. Sorry, it's not that one. Okay. So can you see my screen? Can anyone see this?
Yes, I can see it.
Okay.
Yes.
So this is an example of an SRD. They call it SRD here. Some people can call it BRD. That's business requirement document. This one is system requirement document. Okay. So this SRD has been reviewed, and as you can see, there's an author here. The author is this person here. All right. And then it carries a date of when it was done, and then so this person did the initial draft. Okay, mind you, when this person was drafting it, they were probably in a review meeting. All right, so discussing the application and all of that. So the first person to draft this out is who? This person. And it look as if he's the only person though. Maybe because he's the project manager. I This is like the only document I could. I'm sorry, let me admit someone there. This is the only document I could find to make it more clearer to us. Okay, so to make it more clearer to us, this is the only document I could find. So we have this requirement document, and you see version 1. Version 1 is the initial draft. Version 2 is when the changes were done, say after conducting a thorough SRD review session. Right, the additional business requirement after conducting a thorough SRD review session. So you have version 3 here showing addition of business requirements, something something. You see the changes that were made, and an issue list. All right, so we said when you are attending this review meeting, they are discussing issues, discussing defects, discussing implementations and all of that, considering possible scenarios. So they keep reviewing until the document is perfect for implementation. And that's not the only thing. Can you see? So this document was reviewed, after going through the project management office, going to the business people and all of that. Eventually it comes down to the testers. So the person here as at that time, I think that's the test manager, so had to go through it, and then make some corrections, add comments and on it, and then he had to be reviewed and all of that, right? So you can see that each of the requirements is carrying an ID. This is how a business requirement look like. BR001, and then you write the requirements. You understand? So anybody that carries this document, number one, they will understand what the purpose of the document is. They will understand the background, or if the application has been implemented before. Now maybe it's just an upgrade. We understand by the time they read through the project background, they get to understand. So they understand the goals of the project, and then they read through the requirements, and this we help them. So say issue list. All right, so application issue list, traceability matrix. So this is how a traceability matrix is. I was explaining last week. I said when you are comparing functional this functional requirement is what has been designed. You're comparing it to the business requirement of what is on this document. There is BR001. If you come here, you will see BR001. This is BR001. So you're comparing it to a certain FR001. Your FR001 is probably your functional requirement document that is in another document, or it can also be the one that has already been written in your test case document. So your test case document also has its own ID. So it can also fit into here. So you will now be checking, oh, this is what the business people want. Is this what was implemented? You check. If it passed, you check it. Oh, it's checks fine. Then you cross it, checks fine. Then you check this one against this one, check this against this, and all of that. So that's traceability matrix, tracing requirement against implemented functions. Okay, yeah, in fact they even combine the functional requirement together in this document. So that's how that's how it look like, just for you to have an idea of how some of these documents look like and how the review is being done. All right, this whatever sign off you are looking at here, is what we call sign off, because it's a sign off document. By the time they are signing off, they already are proving that this document is good to go, and after now they should start the implementation. All right. So that is that about that. So let's continue with our presentation, our class. So continue now. Where did we stop? Okay. We're talking about dynamic testing. Let's go back. Okay. So we said from test case design and implementation to test environment setup to test execution and to what? And to bug reporting. That's how dynamic testing is being done. You design your test case, you implement it, it's implemented, and then environment, that's the test environment. That's where you get to assess the application or the application on that test, the environment that is set up for it. That's what we call your test environment setup. And then from when you actually run your test cases and execute them, and you check that actual result is the same or not the same as expected result, and then you get to report defects and all of that. That's what we call dynamic. That is, it's not static. You are getting to do stuffs, you are checking documents, you are running tests, you are reporting bugs, you are doing everything that is being I mean, you are doing everything you're supposed to do. You are testing. Let me just put it that way. That's what we call dynamic testing, and that's what you should be doing as a software tester every day. So we have categories of test technique. We have the choice of which test technique to use depends on the number of factors. Like I said, there are different factors that will affect the kind of test technique we will use in any software application, depending on the application being tested. Then you to choose which technique you will use in conducting the test. All right. So depending on customer contractual requirement, time and budget, software development life cycle, type of defect expected, you know and so on, that will determine what technique. Now, what are these technique? We have black box test technique, we have white box test technique, we have experience based. We explain all of these three categories one after the other. So the first, black box test technique, you already know what black box is, am I right? When you are conducting a test on an application without really knowing how the code was written, all right, and how the code is written, how the application got to be developed, you're not concerned about that. All you're concerned with is the application on that test. All right. So there are techniques for testing black box kind of test application. All right. So we have equivalence partitioning or equivalence class partitioning. So we said it's a black box technique. As you can see from this diagram, you can see, so it divides the input. It's like you partition the whole test case into valid and invalid values. All right. So, and there are some applications, or there are some scenarios where you will require equivalence partitioning. It said, let me read this out to you, which can be applied to all levels of software testing like unit, integration system. In this technique, input data units are divided into equivalent partition that can be used to derive test cases, which reduces time required for testing because of small number of test cases. So when, especially this is especially used when you are dealing with number range. All right. So let's look for an example. I have an example here that I have opened on my browser, and I'm going to share my screen for that. All right. So we'll consider that, but before we consider that, let's look at this time line, this number line. All right. So in this number line, they are trying to consider numbers from 1 to 10 as valid, and they're trying to say from 11 to 99 this will be invalid. You are saying that this test cases under from number 1 to 10, they will pass, they will be considered valid, they will pass. But when they fall between this range 11 to 99, they'll be considered as what? Invalid. And if they fall from more than 99, they will still be invalid. If they fall below 1, it will be considered what? As invalid. I hope you already know the kind of application you can test that way. Example is phone number, bank account number, and some other things. All right. So yes, you are checking that, for example, you are checking that the phone number will not exceed what? 11 values. So if you come here now, if it is that one you are trying to test for, then you can say that from you can test that it has to be what? It has to be 11 in length, right? So if it is more than 11, like 12, and then between 12 and 15 or whatever is invalid. And if it is from 11 and below to 1 and to 0, it is what? Invalid, and so on. So that's the way you check for those kind of, you perform an equivalence partitioning. But this will not explain the equivalent partitioning I want you to understand. So I will share my screen now. We will see a live example of equivalence partitioning. All right. Give me a second. Okay. 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 So the principle of equivalence partitioning. Let's go. I don't know if this thing is bright enough. Okay. There's an example. Okay. So we have an example here. Let's use this example. They said following password field the following password field accepts minimum 6 characters and maximum of 10 characters. That means results for values in partition 0 to 5, 6 to 10, 11 to 14 should be equivalent. That is what equivalent partition. You're partitioning your test case, particular test case, you are partitioning it in such a way that you try to get valid values, that is test cases that will pass, and invalid values, the ones that will fail a particular test. All right. So it is a testing technique. That's what you should know. It's a testing technique. So for you to test for a password here, in some password has requirement. They will say the password should have a capital letter, should have one special character, should not be more than 8, or should be 8 in length. All right. And different requirement, maybe that's what has been given, all right, for you to test. Like in this example, the only requirement given is that the password field should accept a minimum of 6 characters. All right. So and a maximum, so meaning that if you enter less than 6 characters in length, what should happen? It should be considered as invalid, meaning that test case will fail. I don't know if you are understanding what I'm saying. So this means that if it is less than what? 6 characters, what will happen? it will fail. So but if it is 6 characters, if between 6 characters and the maximum value, which is 10 character, what happen? You get to pass. And if it is beyond, if it is beyond 10, just like, I actually extracted this image from this page. So this is how the partition was done for this particular um password password test case. All right, they said the password test case says something. It says, is it the image? I don't think it's the image. Because it's only 6 to 10. Okay, it's not the image. It's from another page. Okay. So if we are to do this partition, all right, this part 0 to 5 is going to be where? It's going to belong to the part of invalid, right? Am I right? So 6 to 10 is going to belong to what? Valid. And 11 to 14 is going to be what? Invalid. Then you cannot say 15 and above, also invalid. Okay, so that is how it will look like. So let's try to do that. So I enter a password. I call it Temi. Temi is 4 characters. Should it pass or fail? Right, it should fail. So if I click here and submit, so this thing prompts me and says enter between 6 to 10 characters. Then I click OK. So if I write a test case to say that if the password lesser than minimum value 6 characters is entered, then the test case should to fail, or then a prompt should be returned. All right, should be displayed on the screen for users to see. All right, so now we are saying that this particular one has failed. Why? Because the requirement is saying that a minimum of 6, and this user has entered what? 4. Another 4. So because it has entered 4, by the time this user is clicking on submitting, it should not allow this user to log in, right? This user should not be able to log in. It should prompt the user to enter what? To enter a minimum of 6 character. That is how it should be. So if you have designed a test case like this, then you can add more suggestion. Maybe if this one has failed, then you can add more suggestion that okay, a prompt should be displayed if prompt is not being displayed, and all of that. So let's do for 6 character. If I enter Temi Tope, Temi Tope is how many characters again? That's 8, right? So meaning that it falls in between from 6 to 10. So it says a minimum of 6 and a maximum of 10. So if it falls between 6 and 10, then it should pass, right? So if I submit, it says success. Okay, right? So that means that this test case should pass. So as you can see, this is a test technique. So what this person is trying to do is to test password field, and to check that people cannot actually log in with lesser than 6 characters or with more than 10 characters according to the requirements, right? So let's go again. Let's check for if it is more than the maximum. All right, so what equalization is saying is that it divides a testing technique into minimum and maximum values, all right, such that it checks for valid and what? Invalid values. Okay, so and by checking for very invalid values, it is equally being partitioned. That's what it means. It is equally being partitioned into values that are valid and values that are what? Invalid. Okay, so we have let's enter software testing. For example, software testing is long, and I'm sure it is more than 10. So let's submit. You say, oh, enter between 6 to 10 characters. Click OK. All right, so when you start designing your test case for this particular scenario, for example, we mentioned scenario the other time. We said in a scenario you can have a lot of test cases. So the scenario here is saying validate password. That is your scenario. But what should be the test cases that should be under validating of password? You're saying that um character, let's see now, that validate that user cannot enter um lesser than the minimum value, right? Validate that user cannot enter lesser than the minimum value. That should be the first one, which is like 0 to 5. Then validate that user can enter that when user enter the minimum, from the minimum to the maximum value, that is 6 characters to 10 characters, then they should be able to what, submit, or they should be able to log in. That's another one. Then you're also checking that validate that when user enter more than the maximum value, that is more than 10 characters and above, then they should not be able to log in, or the system accept should not accept the password. All right, so these are like the test cases, these are the scenario description, so and all of that. So this is a scenario description, but it's not the test case. By the time you're writing the test case, you write it the way I said it just now. So when we get to writing, really writing, I mean the syntax and all of that, we will get to discuss that. But for now, what we are discussing is um testing technique. All right, so I hope we understand what equivalence partitioning is all about. Let's move on. We have boundary value testing. I think there's an example of boundary value testing in this same page, so I will not close it. So we have boundary value testing, and in boundary value testing, you test two extreme ends. That is, you test two boundaries. You test between two boundaries. Okay, so it's also related to equivalence partitioning, in that in boundary you get to talk about minimum and maximum, and also in equivalence you get to talk about minimum and maximum also. That's how it is related. But in boundary value, you also you do more. It's not just equal partitioning. Here you are talking about values just above the minimum, values just below the maximum, and nominal value. How then do we explain this? Let's look at an example. Okay, so we can make use of this example. Okay. So we can make use of this example to test, to what is the requirement now. Okay, we said the following password field accept minimum of 6 characters and a maximum of 10 characters. If I am to use BV, that is boundary value technique, to test this particular this same scenario, if I'm to use boundary value, how do I go about it? Number one, you must take note of the minimum value. What is the minimum value here? We say 6. All right, so 6 is valid when you are talking about, so it's valid. That's minimum. Then you consider a value just above the minimum. Value just above the minimum talks about what? 7, 8, 9. Those are values just above the minimum, and value just above the minimum is considered as what? Valid. Now there's something called nominal value. That one gets to stay just in between the minimum and the maximum. So in between the minimum and the maximum is also still valid. And just below the maximum talks about values closer to the maximum, but not more than the maximum. So if you are talking about maximum here, we are talking about 10, but the values just below 10 is what? Is 9. So 9 is considered valid. Why? It is just below the maximum. Now the maximum is 10. 10 is also valid. So we are saying every value that falls between minimum, just above the minimum, a nominal value just below the maximum, and maximum are considered valid when you are performing boundary value testing, and every other value outside of all of these are considered invalid, meaning that the value just before minimum, that is, this minimum is 5. Just before this minimum is what? 4, 3, 2, 1, 0. Values just before this minimum are what? Invalid. Now, values just after the maximum, that's 11, 12, 13, 14 and above, they are considered what? Invalid. So that is what boundary value is saying. They say values within the boundary minimum and maximum are considered valid, while values outside of the minimum and maximum are considered invalid. That is what boundary value testing, and we have considered this scenario already. We've checked it with equivalent partitioning, and we've seen how it works. All right, so that is how boundary value works. Okay, now let me just just so you see an image. I think I have a do I have I think I have Okay, so this is how. Can you see my screen, my PowerPoint? Let me go back to my PowerPoint so that you can see. Okay. So this is how. So you are trying to test and you are confused, you can just draw out this line and try to fix in your values like this. Okay, so we are saying values in between the boundary A and B is considered what? Valid. That is the minimum and maximum. So minimum and value just close to the minimum, the nominal, then the maximum, the maximum and value close to the maximum, they are all what? Valid. But values outside of the maximum, and our values outside of the minimum, that is from this point to this side, from this point to this side, are what? Invalid. So that's how it looks like if you are to draw it on a number line. All right, let's continue. So we have talked about this. All right, we said, no, as you're looking at this now, you already know what equivalent partition is in this diagram, right? This is the equivalent partition, and this is what? Boundary value. You can see from the way it is drawn, boundary from 1 to 10, right? From 1 to 10, this is boundary value, definitely. So you are saying that it is only valid from this to this. Every other values outside of this remains what? Invalid. Now, if you come to equivalent partition here, right, you are saying that from the minimum, maybe the minimum here is 1, and then the maximum here is what? Is 10. So from the minimum to the maximum here is valid. All right, so but there's a value just below the minimum which is invalid, and which is like the first partition, and there is another one just above the maximum, all right, and which is like the third partition, moving from 11 to 99. Then there is another one more than what? 99, which is 100. So anyway, any value outside of the valid partition is what? Invalid. All right, so if anyone value from the set passes the test, then the whole set of partition is considered pass or valid. So if any of the test cases you perform within this partition, if it passes, then it passes, it's considered valid, and all of this are considered invalid, that is, they fail. All right, so let's continue. The next testing technique that we'll consider is what we call decision table. So decision table testing is a software testing technique that is used to test system behavior for different input combinations. So each column responds to a decision rule that defines a unique combination of conditions which will result in the execution of actions. The values of the conditions and the actions are usually shown as Boolean true or false, or district value, e.g. red, green, blue, but can also be numbers or range of numbers. So these different types of condition and actions might be found together in the same table. So what we are saying is decision table is checking, making decision is like saying, okay, true. If you combine this first condition and second condition together, then you should have a true. If you combine this second condition and this third condition together, you should have a false. That's what it means, that you are combining some different set of input to get an output, and the output is making a decision true or false. All right, so we should consider an example. So I think I have an example here. So we have an action saying that account already approved. Okay, so if we also have OTP matched, sufficient money in account. Then we have transfer money, show a message as insufficient, block the transaction. So let me look for something you can understand better before we come back here again. I have something here you can check. Okay. Okay, yeah, something that you can better understand before going into an account. We can use a login template to check. So let me share this so that you be able to understand. Okay. So can you see my screen? So I have an example here talking
Yes.
about I have an example here talking about how to make decision table decision based table for login screen. So now they want to apply a decision table technique to test um a login screen, a login page. How do you do that? We have email field here, we have password field here, and you want to check if user can log in. So remember we said you are checking for, if you combine some set of inputs together, will you be able to get the required output. So the required output is the one that will make the decision true or false. All right. So just imagine I entered an invalid email. Maybe I entered temitope.oyedemi at gmail.co, or maybe I put temitope.oyedemi 19. My email normally should be temitope.oyedemi, right, at gmail.com, but I entered 19 and then I entered password. But the system already registered the actual email, which is temitope.oyedemi at gmail.com. So imagine I'm now trying to register, I've signed up with a valid email already before now. Now I want to log in. Now I'm trying to log in with a wrong email. What should this login, what should it do? What should be the expected result? The expected result is that if I log in with valid email and the valid password, I should be able to log in successfully. And if I log in with invalid email, and even if my password is valid, then it should not what I should not be able to log in successfully, right? So that is how decision table comes into play. So you are saying that if user inputs valid value, even if the other value is invalid, then if the other value is invalid, then the user should not be able to proceed. That is the result of a valid, which is a true, and the result of an invalid, which is a false, should give us a false. That's what it means. All right. So, and it's also saying that if you combine a false email, which is an invalid email, and you combine a false password as an invalid password, then it should also be false. That is, the result of a false should be what? Should be false. That is, I shouldn't be able to log in. Now we are also saying that if I now combine um a valid email, let's assume my email is valid this time around, that is a true, and an invalid password and a false, it should also still give me what? A false, right? So it should still log me out. I shouldn't be able to log in. Then the only way I can log in is if my email is what? True, and my password is true. That is valid email and valid password. So how many test cases have we been able to generate like that? If you are following. So it's a testing technique, and while trying to test, of course, you are writing your test cases. I mean, you're writing your test cases. You've written your test cases before you execute, mind you. And the way you write your test cases depends on what the application you are testing is all about, and the way you're going to execute is also depending on what test cases you have written, like we said. So, but looking at this scenario now, if you have written a wrong test case, you have a problem. So it means that when you're writing test case for this kind of scenario, you have to follow decision table testing technique. All right. So if you follow decision table testing technique, the first thing you check for is what? True false. All right. False true, false false, and then what? True true. All right. Look at it here. False false, if you combine false username, false password, then what should you have? It should be false. That is, you should not be able to you should exit. I mean, you should not be able to log in. Then if you have true false, what should happen? You should not be able to log in. If you have false and true, you should not be able to log in. But if you have what? True and true, then you should be able to log in. So that is how it works, and I think that was what I was trying to explain with the example in the slide. So the example in the slide is saying if you combine true 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 true, and if only one is false, then you will still have a false. If you combine, if everything is true true true, and then you still have, so that is how it is with decision table. Okay, so this H here is saying home screen is displayed. This is saying error message. Okay, so you should have an error message and so on. So when you're writing your test cases, you're saying that you validate that when user enters an invalid username and an invalid password, then an error message should be displayed. That is your first test case. Then you're saying that you validate that when user enters a valid email and an invalid password, then an error message should be displayed. All right, not just displayed, then user should not be able to log in. Then you are saying that when user enters a false, that is an invalid username, an invalid password, then an error message should be displayed and they should not be able to log in. Then you're saying if a user enters a valid email and a valid password, alright, validate that if a user enters a valid email and a valid password, then they should be able to log in to the home page. Alright, so that is that with the example. Let's move on to our PowerPoint because of the time. Okay, so continue. Okay, so we have number 4, state transition testing. So we say changes made in input conditions cause state changes or output changes in the application under test. State transition testing helps to analyze behavior of an application for different input conditions. A transition is initiated by an event, e.g., user input of a value into a field then the event result in a transition. The same event can result in two or more different transitions from the same state. All right. So what transition, from the word transition, you already know that it's changing states from one state to what, another. So when you combine some set of inputs, you get some output. So the result of that output can be transitioned to the next output, and when it transitions to the next output, it becomes a different state. All right. So that's how. So if you are given this kind of scenario where state changes, for example, I put something here. I said a USSD code to subscribe to a data plan. So I know a lot of us do data subscription. So let's say, for example, you're trying to do data subscription for Airtel, for MTN, whatever. All right. So you enter a code. All right. So and they ask you to enter number one, and then you select number one. You know, the result of you selecting number one will transition into the next page. All right. So whatever you select in the next page, we transition to the other next page again. Whatever you select in the next, we do what? We transition to the next. All right. So changing of state from one, whereby whatever the input you have put in one will reflect in the next state. You have to conduct a state transition testing for those kind of application. Do I have an example? I think I should have an example. Much more than USSD. Okay, so let's look at this diagram. This is for this is another one we are familiar with. We have, if you want to change your pin, all right, so you slot in your card, right, and then that is start. So on the first try, if it is correct pin, you are what, you are granted access. So the first thing you do is you slot in your card. So that's one action. Then it led to another one, that is you were able to enter your pin. It's from right there entering your pin that you were able to grant access. But let's assume you enter the wrong pin. What happens? So if you enter an incorrect pin, then you will be asked to what, to retry. And if you retry and you enter a right pin this time around, what happens? You are granted access. Now if on the third trial, and if on the second trial you enter a wrong pin, then you are asked to retry the third time. Now if on the third trial, the way that system is designed is such that it might not be all ATMs. Let's assume this software that we are, as an example, if on the third trial you are supposed to input a correct pin, and you still input a wrong pin, because of security and all of that, we are saying that this system should block the user. All right, we are saying the software should block the user from accessing the account. So on the third trial with an incorrect pin, then the account is what, is blocked. So if you are testing a ATM card pin change and all of that, then the best technique to test it with is what, state transition diagram. All right, just like I mentioned USSD, it's also the best to also use is what, state transition diagram. Let's continue. Okay, so there is another one in here. We have them use case testing. So use case testing, tests can be derived from use cases, which are a specific way of designing interactions with software items. They incorporate requirements for the software functions. Use cases are associated with actors. That is, who are these actors? We are talking about the users, the customers, the external hardware, the token, the special code that is being sent to your mobile phone, the SMS alert, the email notification, and so on. So and subject or system to which the use cases are applied. So this test case helps to identify test cases that cover entire system on a transaction by transaction basis from start to end. So what we are saying is, for use case testing, you are when you have a scenario where you have different users, or where you have to enter token or OTP, or where you have to get an SMS alert. I'm just using scenarios that you are familiar with. Then the best technique to use is what? Use case testing. Why? Because it is easily applicable. You can easily get that token and then impute it. For example, I think there is this thing I put beside it. I said invalid password entered more than 4 times, IP address is banned. Or you can say if OTP is entered after 10 minutes, then maybe you can change password, or then maybe you can log in, or something like that, right? So that is an example of use case. So if it is entered more than 4 times, the address is blocked. If the token has expired, then you can log in, and so on. So those are the examples of what? Use case. Let's continue. We have okay, so we have white box test techniques. Okay, so you remember we talk about the testing technique. We said there's black box test technique, there's white box test technique, and there's experience based test technique. So let's do white box test technique. So it's divided into three. We have statement testing and coverage, decision testing and coverage, and value of statement and decision testing. So it says statement testing exercises the potential executable statements in the code. Coverage is measured as the number of statements executed by the test divided by the number of executable statements in the test object, normally expressed as percentage. So what we are saying is, when you are writing your codes, even if it is not code, it is the way you test. White box is all about code, right? So I don't think it's manual here. It's when you are dealing with unit testing, or when you are dealing with integration testing. So this is where this test technique is applicable. All right, so when you are dealing with unit testing, you can make use of statement testing. For example, you know the number of functions you have written, and then they calculate the test cases you're going to write based on the number of functions. If you are writing it writing one test case per function, or you are writing 3 4 test cases per function. All right, so that's what we call the statement testing and coverage. We also have decision testing and coverage. Decision testing exercise the decision in the code and test the code that is executed based on decision outcomes. To do this, the test cases follow the control flow. So this time around, it's not about the function, it's about the control flow. And let's say it is about the logic, all right, from a decision point. E.g., if an if statement one for if an if for an if statement, one for the true outcome and one for the false outcome. For a case statement, test cases will be required for all possible outcomes. So what you are saying here is, you are writing your test case, your unit test case, for decision test cases. Then for decision testing and coverage, you are writing your test cases based on your if statements, based on your control flows. All right, so another one is the value of statement and decision testing. So when 100% statement coverage is achieved, it ensures that all executable statements in the code have been tested at least once, but it does not ensure that all decision logic has been tested. So if two test box technique if two white box techniques discussed in this syllabus, then statement testing may provide less coverage than decision testing. All right, when 100% coverage is achieved, it execute all decision outcomes, which include testing the true outcome. So what this thing is saying is that it's possible that statement testing does a thorough coverage even more than value testing. So you can just do more research on that, especially when you start writing your unit testing. All right. So let's move on from here. We have experience based testing technique. Now, this one is for the experts or experienced testers. All right. So, from an experienced point of view, a tester's skill or intuition can help them, test an application. So, there are two techniques under this experience based technique. We have error guessing and we have exploratory. So, error guessing is a technique used to anticipate the occurrence of error. You already used with that kind of system, you already know how that kind of application will work, so you already anticipate that in this particular area is prone to errors, is prone to defects and failures. So it is based on testers knowledge, including how the application has worked in the past, what kind of errors tend to be made, failures that have occurred in other applications, and so on. We also have exploratory testing, um talking about from an experience point of view. You don't really have the test cases to this application, but all you just do is to explore the application. So you say the test results are used to learn more about the component. So you go through it, explore it, and the results you get will help to learn more about the application, and with that you get to perform your you get to perform your testing. So that is exploratory testing. So it's also a technique. Oh wow. Oh wow. We were still able to make it. I know I'm going to have a lot of questions today. Anyway, so let's go straight to the questions before we give a summary of what the assignment this week is going to be like. So we have highlight the major differences between static and dynamic testing, research and write on test documentations, that is test suite, test artifacts, test plan, test summary report. Then research and create test scenarios and test cases for cash withdrawal system, assuming all customers are not allowed to withdraw more than sorry, there's a mistake here. Assuming all customers are not allowed to withdraw more than 200k in naira a week and 1 million in naira in a month. So what we are saying is, now, no, we have talked about testing technique and all of that. So you have to consider that when you are looking at this kind of application. So when you are writing your test case for this kind of application, you are thinking about the all the techniques we have talked about. All right. And when you are writing it, you are not just writing it based on um because you've seen it somewhere, or because somebody is discussing it with you somewhere. It is based on your understanding. This is a cash withdrawal system. We talked about ATM machine yesterday. So a cash withdrawal system could be an ATM machine, alright? So it could be an ATM machine. So you can look at it from that perspective. And now we have a condition here, and that condition is saying that for all customers, it doesn't matter whichever category of customer you belong, for all customers you cannot withdraw more than 200k, alright, a week. I'm already looking at the testing technique you can use here. You cannot withdraw more than 200k a week, and in a month you cannot withdraw more than what, 1 million. So let's get the ball rolling, and yeah, so that's the assignment. Now I'll give us space to ask our questions. So questions please, you can raise your hands and we answer you one after the other. Okay, Mohammed, Amza, Usman, you can ask your question.
Good evening, ma. Thank you so much for the class.
Yeah, you're welcome.
My question is about the white box testing.
Okay.
It, you said a lot there, but I can't actually get. I didn't actually understand whether
Whiteboard
because my
testing
worry,
technique, right?
my worry mostly is that are we going to, as new testers, are we going to be engaged in? Because I understand that it has to do with programming, language, and all of that. I don't have any background in that. Is there a kind of arrangement where people don't, some set of persons don't necessarily need to do white box testing,
Okay.
or is it more do for everybody?
Okay, yeah, I think I answered this guy your question last week. Anything white box for now, you don't need to involve yourself in it. What you need right now, this class is majorly for manual testing. If you check the registration, I said manual software testing, A to Z of manual software testing. So I just put that there just so you know that there is white box testing technique also, right? So when you get to the point where you start writing unit test, integration test, you will get to learn testing technique, this kind of white box testing technique. You will get to learn them, but for now you don't need it.
Okay.
Yes.
Okay. So, but also, I don't know if this is the right place to say this, but my assignment, the one the last time submitted,
Okay.
I sent it to your DM directly. I don't know how you did it. You seem not to have seen it. I don't know what channel would have been a proper place to submit.
Okay, you didn't get a response from me.
No, not at all.
Oh, I will check again because I remember I answered everybody.
Okay.
You
Okay.
sent it to my mail, right?
No, I sent it on the
On Slack.
what's the name now? Yes,
Oh,
yes.
oh, that's the problem. Forward it to my
Oh,
email.
okay, okay.
Okay.
I'll do that. All right.
Okay. Yeah, thank you. Okay. Any other question? Question, please. Question. Okay. Yusuf, you can ask your question.
Hello, good evening, ma'am.
Yeah, good evening.
Thank you for this wonderful session.
You're welcome.
Yes, ma'am, I just want to ask that please, do we get to do like a practical session?
We should have one before the end of this training, right? We'll have one before
Okay,
the end
ma'am.
of this training. So but beyond that, all of this assignment, if you take it serious, then you will have no problem. Like for example, this number 3 on the assignment for this week, in fact, even including the one I gave you last week, I'm very sure if you actually did your homework well, you won't have problem at the end of the day. This is saying write test scenarios and test cases. All right, I think I gave a template how you should write it in this slide. It should be here. Where is it? Somewhere here. So if you are writing test case, mind you, you have to use an Excel sheet. So use an Excel sheet. You have a test case ID, you have the use case, you have the test name, description, and all of that. Okay. So if you are, let me say, if you listen well and you do your research well, then you can learn much more than you think, right? But I will find time, maybe one of the weekends, maybe on the last weekend, where we can actually have a practical class before the presentation class like this. We have a practical class, and then we can go through what you're doing on your own, or I can get to share screen with you on a practical work, right? So on a practical project, so we can do something like that, right?
Okay,
So yeah,
thank you very much.
does that answer your question?
Yeah, thank
Yeah,
you.
yeah. All right, you're welcome. Okay, Samuel, you can ask your question.
All right. Good evening.
Yeah, good evening.
Yeah, please. For the last assignment that I did,